Welcome to the ML Platform Podcast, brought to you by Neptune AI. In a show where Piotr and Arimas, together with top MLOps practitioners, explore the world of internal ML platforms and MLOps stack components. Today, we are joined by Hien Luu from DoorDash to discuss insights into the ML platform at DoorDash, including the challenges they tackled.
They don't have to build a 20-person team initially, but it can build a small team to focus on MLOps infrastructure. We definitely need support on the product management side. Given that as the company grows, product management responsibility will be greater and greater moving forward.
Large language models will work next to deep learning models, maybe via agents, but in many use cases, practical use cases, business use cases, you won't solve them just with large language model, and you will be combining those techniques.
Now onto the show.
Hello, everyone, and welcome to Machine Learning Platform Podcast. As always, together with me, I have my co-host, Piotr Niedźwiedź, who is a founder and CEO at Neptune AI. And today, together with us, we have Hien Luu, who is currently a head of machine learning platform at DoorDash. Hi, Hien. Could you introduce yourself to our listeners?
Yes, thanks for having me in this session. My name is Hien Luu, and I'm currently leading the machine learning platform at DoorDash. Been with the company for about almost 3.5 years now. So it's been a fun journey of joining the company pretty much right at the beginning of the pandemic. So a lot of interesting stories.
So I think we can get into all of these interesting stories during our podcast. But actually, I wanted to go a little bit back in time. So I think that you are probably either the most experienced person, or at least one of the most experienced persons in the industry, people in the industry that you have actually had a chance to have on our podcast. So if I'm correct, you're in big data or analytics for at least 14 years now, right? Am I correct?
That is correct. Yes, I spent quite a bit of time at LinkedIn before DoorDash. Correct.
But you started as software engineer.
Yes, my career was started as a software engineer since I graduated from college. And then my career evolved in terms of different areas. More recent time in the last maybe decade is all about big data and machine learning infrastructure.
And looking at the companies, you've been in big companies like Netflix, LinkedIn, Uber, now DoorDash. Based on your experience, what you saw, how often the model that is being built is truly, let's call it a big data model, a model that has to be distributed, at least the training has to be distributed, versus a model that's use biggerish data, but not really big data. You don't need a cluster to train it. Because I'm asking that because I remember those times of big data revolution, and I remember the transition, at least of my interest, more into machine learning, deep learning space. And I've been hearing that yes, maybe big data is needed, but we don't, our models are not so big, realistically. So looking at your experience and the teams you've worked with, what is the ratio? How often you really needed big data?
Yeah, that's a great question. What you observe is reflects what's in the industry. Not all ML models need large amount of volumes of data, which is very true. However, there are certain types of machine learning use cases that can benefit from large amount of data. I think we all know that. Specifically, for example, for Netflix, right? A major part of the business model able to survive and thrive is their recommendation engine. And that recommendation engine is fueled by a large amount of, all the user interaction viewing, movie viewing data and all the other stuff really help making their recommendation powerful and relevant and all that good stuff.
When it comes to these specific, for example, Netflix use cases, so did you see the pre-processing being as big? or also the actual features that you would feed to a model? Because naturally, yes, the pre-processing is huge, right? Because you need to combine all of the data sets, but do you feed all of that data into machine learning models as well?
Yeah, they do. And they come hand in hand, right? In order to generate all these large volume of features. And the freshness also plays another important aspects of these kinds of machine learning use cases of recommendation. So the ability to process these data at high volume, and able to improve the freshness of the data using real-time streaming processing and such. For these kind of use cases, they play a pretty significant role in the model performance. A similar story at LinkedIn, right? So the job search and other search-related use cases, right? You have like millions and millions. I don't know. I forgot the number of users at LinkedIn now. It's quite large at this point. And then that's like very key to the feature set that will go into their job search or job recommendation system. And then you have a large number of jobs being posted on LinkedIn. And then all the companies and all the other aspects that come into the picture when making recommendations. Advertisement is another use case that can really benefit from large amount of volume as well. So not all use cases need large volume of data, but the ones that I see, especially from these three companies, are like recommendation, search, and ads targeting.
Okay, so a question would be like, it's still like you can imagine a few scenarios roll out when it comes to big data and how you use that for training machine learning models. So one would be where you have a really big data set and then you're retraining the model, let's say weekly or daily, to achieve freshness in the actual model itself, or you can continuously fine-tune a deep learning model with new data coming in. So which one was the one that you observed mostly in this company?
Yeah, for these use cases, I think the freshness of the data it's pretty important. So the ability to, successfully generate these feature or run these feature pipelines successfully on daily basis, or probably wouldn't be weekly in these kind of use cases, have to be at least daily. I know that for recommendation, I think Netflix, they started with like offline predictions and then put it in the cache. And then now they move into the world where that cache is being refreshed like every 3 to 4 hours, for example. So it's depending on the use cases. Some use cases like this, the fresher the data or features, the better performance they can get out of them. But not all use cases need that. So it comes down to the kinds of use cases as well.
Talking about relatively frequently updated models, retraining models like daily or 3-4 hours a day, every 3-4 hours. I remember on this podcast we had a discussion around model monitoring, and there was an observation that if you are retraining your models so often, actual performance of model monitoring is not so important, because anyway in 2-3 hours you will have a new version of a model. I don't know how it works in practice, and you sounds like the right guy to ask. What are your thoughts about it? Do you monitor performance of the models on production in such cases?
I have seen that, when you do these kind of things, there's a couple of things. One is either you iterate your model architecture, or you retrain just with the same model architecture, but just fresher data, right? There's two separate scenarios. For the first scenario, you definitely want to monitor your models, because you don't know until you actually put in production, doing A/B testing and all that good stuff. So you want to detect problems as soon as possible. So for that part, I believe it's pretty critical to do that, to have proper monitoring in place. For the second case, like you mentioned, because you're not changing the model architecture, but just retrain. But then you have to think about, okay, the data pipeline could go wrong. Something could be messed up in the data itself. Hopefully there's data validation along your data feature generation pipelines and whatnot. But there's still that chance where certain values might have changed, right? It used to be XYZ, now is ABC, even though it's the same value and same type. So that could influence the model performance. So the same with that argument, I believe it's still very, very important to have the proper monitoring going on.
Makes sense. Plus, you quite likely, in such scenario of frequent retraining, want to use almost all data for retraining, right? Because you want to get the latest data to have this model as accurate as possible. So it is not so easy to really test it, especially in a recommender system setup after training.
And we know that data changes over time, evolve over time, right? Somebody changed a column from integer to flow or a string, whatever that is. And so, yeah, unless you freeze everything, then you probably don't need monitoring.
So Hien, you were kind of, as mentioned already, involved in big companies, in machine learning platforms of big companies, building them, right? Did you see, what are the main patterns that repeat from company to company when it comes to these kind of giants, right? And maybe something worth mentioning that is kind of similar and maybe different.
In terms of building their ML infra, or in terms of adopting technologies, or maybe both?
Maybe ML infra.
What I've seen is I think it's very applicable for most companies. Essentially, their journey of adopting machine learning, and we also know that the ML AI area evolves over time as well, right? New algorithms and such. For these big companies, there's an ML platform and infra team. Their goal is to help all the product teams in terms of applying machine learning as quickly, as easily as possible. So their infrastructure evolves over time as well. There's a certain core pieces or customers that they work with initially to enable those use cases, and learn from those and build an infrastructure that other teams can leverage after that. It's almost like you building, a product from a startup company, right? You partner with some key early design partners and gain experience from there and build your product based on that. And then you expand that product footprint out to support other customers in the future and such. It's kind of similar in that sense. But the difference is these internal teams, so they can work closely together, very closely, and then they can move fast. And then for these companies, that a little bit interesting, maybe a little bit different than MLOps startup and company, is the scale that they have to deal with. The case of Netflix, LinkedIn, Uber, when the company gets bigger, we're talking about large model, we're talking about large volume of data. Supporting those scale, it's very, very challenging. And then you have to also think about the efficiency aspects of it. You can think about throwing more hardware to the problem, but at a certain point, the cost becoming too significant. So optimization is, at a certain point, will become a big part of the engineering work that the ML infra team has to deal with. And engineers love that kind of optimization problem, obviously. And it also plays a pretty key impact in terms of reducing costs for a company at the same time. Reducing costs as well as able to improve, for example, prediction latency, right? So that's kind of what I see from patterns from these companies. They start out small, working with key partners on certain hero use cases. As the company scales up, different problems comes into the picture. Then they pivot and solve those kind of optimization And obviously, catching up with all the technologies that's evolving rapidly in the field at the same time.
And like to give us some examples of the scale. Let's take LinkedIn. You've been engineering manager of AI infrastructure. Well, it was 2017. Was it the time when they were establishing a kind of AI infra team from scratch, or it was already present when you joined?
This is also a pattern I see as well. And I think a lot of companies can learn from that they don't have to go through that same journey. Essentially, some pocket of the company that are really heavy at applying machine learning to solve that problem. So they start this tight group within that organization to help them. And then gradually the company recognizes that hey, this is something that can be leveraged by multiple teams. Then they say, oh, let's start a horizontal machine learning infrastructure team and formalize that team and then fund that team to build solutions and products that are applicable for multiple teams. So this is very common. It's very common across the industry in the early days, right? But now when, startups or other companies that are applying machine learning, they don't have to go through that same path because they recognize that it's a common need. It's an MLOps. We know what the needs are. There's a lot of good best practices now, so they can start. They don't have to build like, a 20-person team initially, but they can build a smaller team to focus on MLOps infrastructure. And then, perhaps starting out just partnering with some key teams to start out, but still have that seed investment with that mindset of this is going to be useful across multiple teams.
And do you remember, let's take DoorDash. What was it like that it started from some, let's say, one team solving, I bet, key important problem? What was the problem? What was the main or challenge, infrastructure related and platform related challenge that team had?
Exactly, a similar pattern, right? So the team that in the early days at DoorDash that are heavily applying machine learning is the logistics team. Essentially, the team that responsible for that dispatching orders to dashers, managing the life cycle of orders as they go through different stages, right? Prediction of ETA, when the food will arrive at our doorstep. So that is one of the earliest team at DoorDash that, using a lot of machine learning. And that's both like batch inference or predictions, as well as some online use cases.
And I'm just curious, like online predictions, it's kind of easy to imagine that somebody order food. I want to know when it will be delivered. So it's, I bet, online, right? You didn't know, or maybe you already knew that I am going to order pizza again at the evening. But what are the batch use cases?
The batch inference use case, that's no longer the case anymore because it's easy to start with batch prediction essentially for most ML use cases. But they're coming back to the question about like what are the challenges that they have, and it comes down to scale. And this story is in one of the blogs that we publish out. This is at the beginning of the pandemic, and their first generation of model prediction service was not able to keep up with the volume of prediction that's needed due to that spike. So at the same time, the company decided to invest in building out a ML platform team, like my team essentially. So we partner with them in terms of trying to solve that problem. We also recognize that the model prediction platform it's something that will be useful to other teams at DoorDash as well in the future. So we partner with them and essentially build a new generation of model prediction platform that can scale. And then essentially their team is the first customer for our model prediction platform.
And here, like talking about model prediction platform and this particular case. So for me, it's okay. What I would expect or assume, but quite likely wrongly, I would assume that the model quite likely was a kind of web service. So if there is a spike, I also would assume that you are running it on some cloud provider, so you can out of the box auto scale the endpoints. And when it comes to predictions, yeah, like why was it problematic? But maybe those assumptions are just wrong.
Yeah, there's a couple of nuances around model prediction that is different than a typical traditional microservice. And a couple of those things are, for example, depends on how you architecture it in terms of feature fetching, right? And model prediction, you need features in order to perform predictions. So who does the feature fetching? Is it the client side or the server side, right? So you have options on those. The client side, the cost of that is you have to send all those features over the network. Versus the server side, it can perform model feature fetching based on the clients, and it's closer to the server. And also the client side wouldn't have to be worried about all the complexities of fetching those features. So our model performance or prediction platform, it's about fetching features on the server side. Because we can do it centrally, we can do it more optimally, we can do it more efficiently, and easier for our clients to use our model prediction service.
So otherwise, like, do I understand it correctly? Otherwise, the features will be pulled, collected by my mobile app, and then sent to a model? Like, client in this context, what is the client? Server,
Yeah, the client is actually the logistics platform, not the actual consumer, but the upstream service, the product service that are customers of our model prediction platform.
Why are the servers closer to the features? Because you can deploy your then clients also close to the features, right? Or am I missing something in this puzzle?
Actually, you can, in terms of deployment, you can control where you want to deploy, either co-locate or whatever that is. And I think the biggest advantage is it makes it extremely easy for our upstream service to integrate with our model serving platform. All they have to do or worry about is defining features and tell our platform, hey, by the way, also uploading to our feature store. So the client team don't have to be responsible for all the nitty-gritty infrastructure of managing those uploads. We do that on our behalf. We manage the feature store, in this case, on behalf of our clients. So all the clients or upstream services need to do is just use our library, specify what model they want to perform predictions on, only send the necessary features as part of that request, and then everything else will be taken care of by the platform side.
If it is not a secret, can you share with us what is the order of magnitude of requests for predictions, let's say, on Friday evening in the US?
Yeah, Friday it's probably the heaviest traffic, I think, in terms of traffic power wise, for our kinds of.
It is the time when I have my pizza, so that's why I'm asking.
Yeah, I don't have that granular details in terms of the volume at certain hours. What we do know, and it's already published in one of the blogs, is And we track it also every week in terms of the weekly volume of predictions. And currently it's, I think daily we're probably doing 20 plus billion daily across all the use cases at DoorDash. Right? It is a lot. And so our model prediction platform is like one of the largest services at DoorDash.
Let's say you have some traffic on Thursdays evening. So is it double or triple on, let's say, Fridays evenings? And in this case, how do you manage all of the scaling, right? How do you scale your services? Is it cloud? Is it on-prem?
Oh yeah, DoorDash is on the cloud. It's pretty, it's all public, so nothing new there. And so yeah, over the last, I don't know, 6 to 9 months now, we've been focusing on like how to make the scaling, how to make our platform more efficient, because the moment you operate at scale, right, small gain will become very, very impactful in terms, because it's over every day, right? So we've been applying like auto scaling techniques based on the traffic pattern. The traffic pattern is pretty obvious, right? So we scale up based on the traffic pattern. We scale down when the traffic dies down quite a bit at night. And that's one of the ways for us to be more efficient at costs and other things. So this kind of comes down to not so much about machine learning anymore. It's all about how are you managing large scale microservices. So those techniques are very common.
Is it only microservices, or do you also have some streaming use cases? Because when I was kind of also working in e-commerce, it was e-commerce, but it had very similar problem where you would you would have to scale up in weekends and scale down during the week. But the most difficult problem was in streaming services, because it's really hard to scale up and down streaming storage. Do you have any examples of this, or was it only microservices?
Yeah, in our case, it's not streaming. When you say streaming, do you talking about like streaming content or streaming?
No. So it's just streaming platforms. Like, for example, you're collecting web traffic, right? So this is probably these events are probably hitting Kafka clusters or Kinesis or PubSub or something similar, right? And then the storages themselves, streaming storages, are very hard to scale down and up. So I was wondering, maybe you have some real life examples of how you would do that.
Yeah, in our case, it's all about like model prediction. So it's more on the microservices rather than the streaming platform, like you mentioned. You're right that for streaming, it's not as easy in terms of doing auto scaling based on the traffic pattern.
Out of curiosity, are like when it comes to you mentioned that DoorDash infrastructure is, at least when it comes to predictions, inference is mostly on or only in the cloud. Do you use one cloud provider? Do you use few cloud providers? And a question: do you have any on-prem infrastructure for training, for instance?
Yeah, at DoorDash right now, everything it's on the cloud. We don't have any on-prem, to my knowledge. A cloud-native company.
So a natural question. I'm kind of playing devil's advocate. Why you have ML platform team? Why not to use, I don't know which cloud you use, let's say AWS.
Yeah.
Why not to use SageMaker for everything? They have a lot of components.
Yes.
Why do you need a platform?
Yeah, that's a good question. And a lot of people ask the same questions as well. Why just go out and adopt these vendors or cloud provider, they so-called ML infrastructure?
Especially in the case, because I've heard different answers to such question. Sometimes people say, but we have also on-prem, and we need to support, or we don't want to be kind of locked into one cloud provider, or different teams use different cloud providers, but in your case, one cloud provider for everything. What is your answer for that?
There's many. It's a fascinating question, and it's very logical. There's many factors that will come into the decision, and I'll walk through those. One of the factors is, when was the platform started? That's one thing, right? So imagine 3.5 years ago, that's when our platform was started. If you think back 3.5 years ago, these vendor solutions, cloud provider solution in the ML infra space was quite nascent at the beginning of that journey. So we did evaluate a SageMaker, by the way, when we started out. But back then, for whatever reason, that we believe we can move faster by doing it ourselves. So the second factor that comes in is velocity. We understand our use cases better than these cloud providers. The ability to move fast, right? If there's a certain problem, we can fix it easily because we know how things work. If you're using a vendor solution, if something goes wrong, they can fix it, but the turnaround time might not be the same as what you need. You know, even though we're running on the cloud, we kind of have our own infrastructure, our own DoorDash specific infrastructure. So integrating the vendor solution with our DoorDash specific infrastructure is another friction point of using vendor solution. And then the fourth one would be like the scale that influence the decision of whether to build versus buy. In our case, it's like most other companies, our platform evolves over time. We're not opposed to like looking out for vendor solution to adopt those when those make sense to solve the specific needs that would also meet the other criteria that we set out in terms of build versus buy strategy. So then the question is, like, if I were to build an ML platform right now versus doing
it's exactly what I wanted to ask.
I believe there's going to be some differences because the maturity in this space is now at a state that is very, very different than 3.5 years ago. So there's no doubt there's going to be part of the platform. Oh yeah, our platform is a mix.
Do you have anything open source or any point solution of current open source MLOps kind of stack out there, right, in your platform?
Yeah, we do. I've been describing that our platform, which consists of many pieces, like similar to other teams or companies in our platform, it's a mix of vendor solution, open source solution, and internally developed solutions. The vendor one is, I think it's out there already. Is we're using Databricks from the early days in terms of helping doing data crunching. And data scientists use part of that notebook services to do their work. And then for some of the open source solution like MLflow, for example, we love MLflow to help with experiment tracking and such. And then for the internally developed solution, the one that I mentioned already is our model prediction platform.
What about model monitoring?
Oh yeah, model monitoring. Right now, it's in a kind of a interesting state. It is a bit nascent from my perspective. I would like to be much better than where it is now. Right now, it's internally developed for just the essential needs at the moment. But I think those needs will become more and more complex over time as we have more and more use cases, as we operate across the world moving forward. So the needs to analyze and understand what's going on will be more complex over time. And I think that's definitely an area that we will be looking in, I think, early next year to see if a vendor solution makes sense or not for that platform.
Is it one of the key challenges for your platform team for the next year, or there are also other important topics? And if yes, what do you have on your plate?
It will be. I think it will be a key piece moving forward. So far, we're just building enough functionality to meet those needs. because there are other higher priorities. But as the other priorities have been tackled, then this one's gonna be emerge as one of the higher ones in next year.
So my question is, how many people do you have in your specifically your machine learning platform team that builds the platform itself?
At the moment, I think we have about 12 or 13 folks on my team at the moment.
13, 1-3?
Yeah.
And how many users? How many data scientists, ML engineers are using your platform?
Yeah, we're kind of collapsing that term now in terms of MLEs and data scientists.
So it will be the same.
In the broader sense, I call them ML community.
Okay.
But it's actually kind of the same thing. I think we are 100, last I look up, probably 100, I don't know, 110, 120-ish combined.
So getting back to your team, 13 people, can you share with us the distribution of the roles? Yes, the structure, and do you have DevOps people there? Do you have maybe data scientists or ML engineer or members of ML community?
In terms of the ML community. Yeah, we have, I don't know the exact number though. I think the data scientist is definitely less than the MLE. In terms of proportion, probably a third, probably a third of that ML community or data science, roughly. But that number is changing as well. So.
And in your team?
My team, like I mentioned, we are back-end engineers, essentially. We don't have any data scientists on my team at all.
Some DevOps engineers?
We are responsible for building, supporting, and operating.
So full stack.
Full stack. We don't have any dedicated SRE or anything like that on our team.
And let's take a look at the model on production. Who is responsible for having it, keeping it alive, keeping it in a quality, making sure that it works? Who, let's say that there is some problems, who would be called at the night?
So there are two parts, to be more specific. Like the ML observability piece, then that will go through the model owner, right? Because they're actually using our ML observability capability to monitor and set alerts on those. Now, for model prediction, at the moment, my team is responsible for that.
So you're also operating. You're not only building the tools, but also kind of providing a service of hosting those tools and servicing them.
So right now, it's a bit challenging because we are responsible for all these aspects on the model side. I don't know if you know, but recently I did a quick survey on LinkedIn in terms of what we call centralized versus decentralized of operating and managing model prediction service.
Can you share the results?
Yeah, I'll share that on LinkedIn shortly. But because LinkedIn allows me to ask only one question, so I wasn't able to add a second question, which is like the company size, because that has a big influence on that. Based on the result, it's 50-50.
So it would be nice to know how it is, how it works depending on the company size.
Yeah, I think a couple of factors is when the company gets bigger, there are these very large product teams that they have very critical use cases and they want to be in complete control. And they want total isolations from others. Then in those cases, it probably makes sense for those teams to own their own model serving platform, meaning operate and manage and support that. Because at the end of the day, they're responsible for whatever going on in their product engineering product area, right?
But you said own model serving platform. So I was rather thinking that what makes sense is, I don't believe it makes sense so much to have not to have centralized platform team, but you can have a centralized platform team, but still like that produce tools and practices, but it is up to a particular team, product team, to use those tools and operate. So
That's exactly right. That's kind of what we're thinking, right? The centralized team can develop these best practices, tooling, infrastructure, but operating and managing and supporting them on a daily basis, the specific product team should be doing that for their area.
especially when models are getting more and more
Exactly.
dependent on other models, on other services, other APIs. And it would be very hard, I think, to a platform to follow this whole ecosystem of
Completely
every
agree. Completely agree.
product in the organization.
Are there any? Do you see any challenges of like pushing out new capabilities to these decentralized mini platforms?
Yeah.
Let's call them. Let's say you're developing something centrally. How do you then efficiently push that out?
That's a
right?
great observation. I think that's very typical in terms of like if you develop a new version of something, how will the other team adopt such? What are the challenges of getting those teams to adopt those? And I think you can think of this two different ways. If the new version of whatever you're building provides value for their needs, they're going to adopt it. It's a matter of time. But at the other end, we don't want to be maintaining 20 versions of a library either. So there has to be that balance of, after a certain version, we're going to deprecate the old ones. So that creates that need for other team to, not constantly, but in a certain interval, to upgrade their stuff to leverage our libraries.
Sounds close to product management problems.
Very much. Very much.
Do you have people with product managerial skills or experience?
That's a good question. The reason I laugh is we don't at the moment. So my team is essentially doing product management, building, supporting, operating at the moment. My hope is in the near future that will change. For us to be able to scale, we definitely need support on the product management side. Given that as the company grows, product management responsibility will be greater and greater moving forward.
Yeah, and this is something that I guess we see commonly, right, in the machine learning platforms. That it kind of members themselves. Sometimes, usually, it's covered by the team lead of a machine learning platform, right? The project management aspect of it, like going out to the rest of the company and figuring out what to build and what's of the most importance to the use cases.
It's actually an observation we started using in the recruitment processes. When you want to find the right product manager for a company like Neptune, we definitely need product managerial skills, but we also need a person who understands the market, who understands the problems. And so, as you can imagine, it is not so easy to find one person with both skills. But members of ML platform teams, even though they would very often say, no, I don't have product management skill set and experience, effectively what they do, part of it at least, is product management, because they're not building it for themselves.
Yeah, that's true. Yeah, it's very interesting. I mean, there's certain engineers that have that product mindset more than others. I think those potentially can play a bigger role in terms of the product management for the team. So maybe you can think about having those folks spending, I don't know, north of 50% of their time on product management and the remaining time on engineering, potentially, to fulfill some of those needs that the companies have.
What do you think are the most impactful processes that are kind of related to product management that bring the most value to machine learning platforms, building machine learning platforms, understanding the needs of the company, and what should be built next?
Because the number of customers or internal teams that are using machine learning platform is increasing. And some of those teams are like fairly new as well because of new product. So the product management aspect comes into those pictures very valuable in terms of understanding those teams' needs and understanding where the platform is and their capabilities, and then figuring out the right pieces that we need to build to support and anticipate those use cases is extremely important. Because many teams are depending on us for their own project, right? So we need to align with them in terms of their needs and timeline at the same time.
And Hien, do you have internal documentation of your ML platform components?
Yeah, we do.
What is the quality of it? Who is writing it?
Not very good.
It's a challenge.
Essentially, we're asking engineers to be tech writers, right? Some of them are good, some of them are not so good. And some of them would like to do more engineering work than writing. So,
Not surprisingly.
yeah, not surprisingly.
I don't know many engineers who like and can write a good docs.
One thing that has helped us a little bit is in terms of like planning wise. If we were going to build a new feature, for example, then we want to make sure to incorporate a task or a certain amount of time for documentation. So we want to make it explicit as part of that deliverable. That way it's not an afterthought, right? That way we actually allocate time for the engineers to do so. That has helped us a little bit.
Have you tested, I've heard about approach that is quite close to test-driven development. Maybe it would be documentation-driven, I don't know, maybe there's a term, DDD, documentation-driven development. You start from documentation. It is kind of a, I think it's similar to writing API, the contract, like, okay, we will provide this, it will work like that. And you collect the feedback for the documentation, and then once we all agree that it is how it's going to work, then you code it, then you implement the rest.
I definitely see some potential value there, because you actually start with thinking about from the product side, from the user side, in terms of how it works and what are the capabilities,
and later
that they're going to be.
But sometimes you can write great docs and propose great experience, great API, but you will end up that it won't work like that, right? Because it's not feasible. But
that's the part that I'm afraid of.
Yeah.
So
I think it is easy when the problem is easy. It is harder when the problem is hard, because it's not obvious that it is doable.
Yeah, unless you do some kind of study or exploratory to validate some of the understandings.
Plus, you want to test how it will work in practice when it comes to performance, etc. Right?
Has your company tried that yet?
At Neptune, we have not, but okay. In my pet project, sometimes I do it for myself because I kind of like structure in general, and clear API and kind of logical is kind of important for me. So when I am starting to write some tool for me, I usually start from, okay, how it should work, what should be the end API. Sometimes successfully, sometimes not. Again, depends on the problem. But I've heard that it is not my invention, that some people practice it. So many people talk today about foundational models, large language models, but at the same time, like it was initially, there was a lot of discussions around it. I hear more and more often voices that is a great tool to play, but we haven't found use cases where we can use it on production. How if you can share, what is your take? What is DoorDash doing with large language models? Do you use them for some use cases? Do you plan to do some research around them? Maybe you have some of them on production already. Where are you?
Yeah, this is a very fascinating topic. I think that's like most other companies, we have a blog out about this. If you haven't seen it, do take a look. But we want to explore and figure out how this can help us in a number of areas. But obviously, still in a very this is a new technology. We want to do it in a safe manner, and along the way, trying to really understand what are some beneficial use cases for it. What we have seen in a company where they take LLMs or OpenAI, for example, are extremely useful for some of the offline use cases that we're testing it out.
I expected actually online kind of support, customer support, but offline is interesting.
Support too, but we want to take a cautious stand on this, right? Because it's actually involving users. So we want to do in such a way that is safe, meaning we start to integrate into our support systems, but do it in a co-pilot manner. So the agent actually have complete control whether to use that what's being generated or not. So support is definitely, I think most team or most company, that's an area that makes a lot of sense to start applying these technologies to it.
But it would be still considered as online, right? Or it is what you meant by offline?
Offline meaning that not customer facing, but doing in an offline manner, right? For this particular one, yes, use case is online, but one is not low latency requirement. For example, like the search team comes to me and asks, "Hey, can we generate these doing like search query intent classification in, I don't know, under 200 milliseconds using LLMs?" That's going to be a big challenge with the current state of things. Maybe in the future, right? So you got to figure out what use cases that can leverage these awesome technology, but doesn't have those like low latency strict requirements.
And search in your context would be, I'm describing a food, right? Would it be this case or?
Yeah, customer come to DoorDash, they can search whatever you type in, the dish type, the restaurant name, all kinds of stuff, right? So one of the needs is like understanding the intent of that query, essentially, and then use that intent to hopefully return the most relevant result to our customers. So yeah, it's been fascinating in terms of us like seeing how LLMs can be applicable for multiple use cases in the company, from external facing product to internal productivities, in terms of generating labels for some of the needs that we have in the company as well. So it's pretty fascinating. I think it's going to be very powerful as we figured out more and more how to work with these technologies.
And how does it impact your team? Because what you mentioned so far, it sounds more as a job, like at least initially for researchers, definitely for data scientists to figure out whether it can be applied or not, but not so much, at least yet, a task for ML platform team. Do you have some?
We're starting to, and I think the couple pieces that we are, start to look into or work on. One of them is undoubtedly there's going to be cases where they're going to need to do some fine tuning with open source model, right? So that's where the ML platform team can come in and help various products team to do that efficiently and easily. We can potentially be the one that help, doing some benchmarking based on our internal data across the different models for the company as well. and then hosting these internal or open source or fine-tuned models internally is another aspect that the platform can provide to the rest of the company.
So it will be open source models and, of course, fine-tuned open source, right? Because
now the question is like, how many use cases will need that moving forward? So that's something we need to figure out as a company. And then for me personally, is like evaluation, large language model evaluation. That's not many people's mind because they just want to play around with this, but they don't really think about if you productionalize these things, how do you make sure that they continue to work the way you expect it to? So like evaluating LLM is a big thing, a top of mind for me.
actually, this I think quite a hot topic in the research, because we need to have, like, there are already some ways of generating some quality number, how well it works, but it is still quite unexplored field.
Is your company doing anything on that front? Just curious.
Let's put it like this. So we are experiment trackers. So we are helping to make use of these calculations, right? So we do not do the calculations ourselves. So we do not evaluate. We do not do evaluation. We help to display and use our frameworks that evaluate large language models in this case, right?
But I think we are kind of following research in this area, because one of the main jobs to be done of experiment tracker like tools is help a team to decide which model should go to production. Of course, understand why, debug it, but with more traditional machine learning or deep learning, usually you had a metric. You did this. You sort your models based on the metric. Maybe you filter out some models that use not the right data, etc. So it was relatively easy. But I think that now it would be hard to say that we have one metric. It would be metric based on for instance, if we take this evaluation model of where you are engaging another, like you are doing kind of L rating, like in chess, comparing models on different prompts, and you have the third model that judge which model won this particular battle. I think we will need to expand our data model and to support a new ways of testing and comparing large language models. If I should, not sure whether I should use large language model or rather large language model plus the way it is being used, prompt agents. This domain got a little bit richer than it used to be, and it is something we need to take into consideration, definitely.
I had one more, by the way. So you talked when you talk about DoorDash and large language models, it seems like you're definitely one of the companies that has figured it out and have defined a clear strategy of what to do with large language models. Was there a point in time when all of this started where management just came in and said, we are using large language models, and everyone started panicking and trying to figure out what to do and didn't have a clear strategy? And how did it kind of evolve into what you currently have? Because I feel like you definitely have a strategy of how you will be leveraging.
Yeah, I think in our case, it helps to have we have the head of data science or machine learning. So that person is the main person that's driving the strategy around adopting, leveraging LLMs and such. So that person has, worked with leadership team in terms of educate the rest of the leadership team in terms of how this might help us and what are the strategy in terms of exploring and identifying potential use cases that we can start with small and then figure it out along the way. So, and then also making sure that as a company that we want to enable the rest of data scientists to able to explore, right? Without exploring, it's hard for the rest of the company to know what can and cannot do. So we want to enable that, but we do want to do so in a safe manner at the same time. So I think that's another very key aspect about this. It's not like some data scientists sit in the lab and do their own thing. We want to enable the rest of the company to have access to these technology, but do so in a safe manner.
Maybe a question like, is there to you, Ken, maybe you would like us to ask you something, like maybe you want to mention or talk about something particular that we have not discussed yet.
Yeah, I think that maybe just one or two things is, I don't know about you, but do you feel like the MLOps topic is now like being shadowed by Gen AI and LLMs? Every day you see a lot of stories, articles about this area, but less and less about MLOps anymore. I don't know. How do you feel about that?
Okay, I don't know whether the absolute number is less, but definitely there are a lot of topics around. Sometimes people call it LLM ops.
Yeah. Yes.
Right. I think it is very close and should be very close. I also believe that MLOps is close to DevOps, but it is another story. I just think that we are like, and I think the relation is quite similar. We have some good practices around DevOps. MLOps workflows brought new requirements, new needs. So I prefer to think about it that we expanded DevOps and call it MLOps. But okay, maybe we've built MLOps looking at DevOps. Philosophical discussion. I think that with large language models and LLMops, it will be actually pretty close, and we would quite likely we will need to add support of another use cases, way of working, way of testing. But I definitely think that large language models will work next to deep learning models, maybe via agents, but in many use cases, practical use cases, business use cases, you won't solve them just with large language model, and you will be combining those techniques.
I agree. I think they will complement each other in terms of these large language model. And regarding to LLM ops and ML ops, I agree with you. I think it's just another layer on top of ML ops. We could brand it ML ops or not, but they are related. But there are also some uniqueness to working with LM as well. So that will be an exciting piece moving forward.
Like for instance, when we discuss product roadmap, we also think about personas, like people who will be using our tool. I think like we acknowledge that we quite likely we should include. I even heard the term AI engineer now. Yes, so it's kind of close to software engineer, but with understanding of basic understanding of machine learning, basic understanding of testing, but an engineer that builds, again, not a model. It's not a person who would do fine tuning of open source model, but a person who will be writing prompts with agents and try to build a software that is using LLM. So, yeah, we'll see. right now we are introducing basics, like basic building blocks that helps you visualize and debug prompts and traces. Talk with our customers, talk with our users. There are we have a lot of data scientists who were also asked by management. I think it is why Arimas brought this question. How did it start at DoorDash? I'm talking about large language models, because very often, based on what we hear, the very first team that is being asked to explore large language models is data science team. Even though if you just want to use, let's say, OpenAI hosted model, do you need to be data scientist? Not really, right?
So thank you for a nice chat, Hien. And before we close up the episode, I wanted to ask you, maybe you want to leave our listeners with some thoughts?
I think the next wave is going to be Gen AI LLMs. So these, at least these are for me personally, are very two exciting areas. So yeah, would encourage everyone to spend time and effort in learning about this area. It's going to be the next wave for both data scientists and the ML infrastructure team at the same time.
Thank you, Hien, and thank you everyone who was listening. And I hope to see you in the next one.
The ML Platform Podcast was brought to you by Neptune AI. If you would like to learn more about ML platforms and MLOps, check our blog at neptune.ai/blog. Follow us on LinkedIn or subscribe to our YouTube channel. Also check out how we help teams solve MLOps challenges with our experiment tracking at neptune.ai. To get notified of future episodes, follow us wherever you get your podcasts. Thanks for listening, and see you next time.